where I'm using two blades, blade 1 and blade 2. So blade 1 and blade 2, they've got operating system. One has Windows, the other one has ESXi operating system. And the CNA, these blades, an MXL switch, and this is the Ethernet link, the one which is marked in blue. This is all Ethernet. I want MXL to play the role of a fiber channel forwarder, okay? And the operating system that is running on MXL right now is DNAS 9, version 9. Your MXL switch has a fiber channel interface, a port, a native fiber channel port, so that it can connect to FC switch. This is an FC switch which is taking care of all the fabric services. Yeah, like zoning. So this fiber channel interface, port number 52, is connected to port number 2 of this Brocade FC switch. And to this Brocade FC switch, we've got some storage. And this storage is induced by Windows and ESX. So they have their compellent storage. Compellent storage is native to we are looking at what configuration needs to be done.
Okay, we know.
So we are looking at what configuration needs to be done on MXL so that MXL can act as a fiber channel forwarder. Let's have a look at it. One, because MXL needs to connect to a Brocade FC switch. You can see the MXL switch has a fiber channel interface. It has a module. This fiber channel, in order to use this fiber channel module to support fiber channel, you have to run the command feature FC. Feature FC is a command that enables fiber channel functionality of that MXL switch so that it can, send and receive on that 52 fiber channel interface number 52. Okay, what next? Now we are talking about these or FCOE frames. Your FCOE frames travel from CNA to MXL. So it is loss happening. So we have to implement data center bridging. DCB. And you know that DCB has 3 protocols, 3 important protocols as part of DCB configuration. If you're talking about making it lossless, you have to make sure that you implement DCB. Now, what's sieging? So, data center bridging has protocols like PFC or traffic based on priority. ET is dealing with TCP is a protocol that is FC, basically your priority settings, bandwidth. In this setup, let's say if you configure something on the CNA, Ethernet traffic 40%, FCOE traffic 60%. Well, that should be the same thing on MXL. These settings should match. There shouldn't be any mismatch. If there is a mismatch, it gives you an error, and optionally, it can correct, that mismatch as well. I mean, this is what, you know, needs to be these three things: PFC, ETS, and DCBX. Okay, go ahead and get this, implement these three things on our MXL switch. So we are creating a map called as SAN underscore DCB. It is nothing but like a profile. And this map has a name. So this is the map, SAN underscore DCB underscore map. Okay. And we are creating two groups. So, hey, there is group number is for group number 0. Now, what is a priority group? I mean, you might be thinking that, hey, what is this, priority? You would have paid attention to the quality of service, QoS. That you would have actually noticed that a priority group is nothing but the type of traffic. Like in the example of an airport, we pass cabin crew, senior citizens, and so on. So these different types of the flight. And the different types of passengers that you have is what we are referring as a priority group. In OS 9, you call it as priority group. So this priority group is nothing but the type of traffic. Yeah. So that's exactly what it says, saying that, okay, we are creating two groups. We're talking about group 1. We would like to give 60% bandwidth. So you can see when it talks about 60% bandwidth, we are talking about bandwidth. You can see bandwidth reservation, which means we are doing ETS. You can see it to group 0. That means one type of traffic. And what about PFC? Do you need PFC for that traffic type 0? Well, the answer to that one is yeah, the answer to that is if I don't want to enable PFC because PFC is needed for FC. FCOE traffic, the fiber channel over Ethernet, it is required. The normal traffic E is set to off. Priority flow control. Get my group one, priority group number one. See, I'm giving ETS enhancement and priority. So C is set to on. So for ETS is configured, PFC protocol have been configured, and these are the two groups, group 0 and group 1. Okay. What about priority? Like, what's the priority number? Because yesterday, when I think I was talking about quality of service, you know, when I delivered this lecture on quality of service, thing it's important we learned about QoS is QoS is to identify. This is like I define which do the tagging, the number, map it to a hardware queue, and configure the queue as strict. Now, I told you that different vendors have different, operating system, and the commands could be different from one vendor to another vendor. The commands could be different. What's important is the concept. What traffic you want to prioritize? What is the priority number? Which hardware queue you want to map, and which hardware queue you want to mark it as strict. These are the four things. So, as I see in this case, there are two groups, and a group one. What is the priority? When I was talking about quality of service, you would have noticed that QoS is something that you can always go ahead and set quality of service number using one P has 7 priorities. I mean 0 to 7, totally 8 priority values. You can have up to 8 priority values, or you can have up to 64 using DSCP. So FCOE, in case of FCOE implementation, we use .1p priorities. So .1p, I told you that .1p gives you up to 8 priorities, and the priority numbers would be starting from 0, 4, 6, and 7. I mean, these are the priority numbers. And if you look at it, what is happening right here, 7. Between 0 to 7 priority numbers, I see we have 2 in group 1. So as far as group 1 is concerned, you can see that group 1 is being assigned with, if you look at the position, position is 0, 1, 2, 3, 4, 5, 6, and 7. These are 0 to 7 values. out of which group number one is actually placed number three to three, where, you know, group number one is placed. That means group one gets a priority of three. Okay. Okay. Now, what is used in the industry is FCOE. They are using priority three. Most of the vendors they use priority for FCOE, though it is not a standard, but it has become a practice in the industry to use priority number three for FCOE traffic. And iSCSI, they use priority number four. For voice traffic, I've seen priority number five. So it's become like they use priority number three for FCOE traffic, priority number four for, you can see group number one gets a priority of three because it is in position number, if you look at the 0, 1, 2, 3, it falls where you have priority number three. And that's how group number one traffic, group one gets a priority of three. And I don't have to, in this case, if I have to talk about this OS9, well, I don't have to mapping hardware queue and marking it as strict because anybody using and for your switches are smart, intelligent to have just automatic to queue which is then that gets processed first. Okay, so they are smart. They just know. So we had two groups, group 0 and 1, out of which we said group number 1 is the one priority number 3. Moment number 3, it knows COE it along to the best hardware queue, which is marked as strict, and then priority done. So what I see is, okay, we are, so these are the default priority numbers. I mean, used in the industry, FCO uses priority 3, iSCSI uses priority number 4. Okay. What CBS, which does what about DCB hacking? Now, your DC is the one that gets enablement you see on a switch. That's ETS and PFC configured. DC, yes, enabled. Automatic enabled. So with these three items, DCB map, your SAN underscore DCB underscore map. So this means PFC, DCBX. So it contains ETS, PFC, DCBX. Part of this map. Yeah. This is what you have as DCB map. Do you understand so far, all of you? Okay, thank you, Lynn. Okay. Now, Um, Now remember your FCOE traffic. We are talking about converged networking. So that traffic, all going through the same. I mean, all going through the same link, right? So it's like internet traffic goes same switch, traffic coming to the same switch. So we would like to make sure two traffics are kept separate. I mean, because they are two different type of traffics. We don't want to mix this traffic, you know. So we would like to have a separate FCOE, and you can create a VOE like VLAN, you know, let's say interface VLAN tab and more capitals. Your station number. So let's say if I'm station, I'll say V100 2 create VLAN 100 2 3 4. What's the FCOE map? What does the FCOE map contain? Like you have DCB map that contains ETS, PFC, and NDCBX settings along the FCOE map is a map that information about what VLAN should be used for traffic. So you create a FCOE map, give some name to that. It's not you're creating, and then fabric for fiber channel and the VLAN. So usually we keep the fabric ID and VLAN is matched like one is we create, right? So it's the same ID. And this is the FCOE map, 0EFC. This is a fiber channel switch, when it has to go ahead. And so if you look at this MXL, when it has to go ahead and issue unique IDs to the FC, which is over here, it uses FC map. 0EFC 00 will be the default one. X stands for your station number, so you can give it. So this FCOE map will contain information about FCOE and Fabrica. Okay, so I have DC map, I have FCOE map. I do take and I make sure that I go to the ports. Okay, I go to the ports. The ports, basically the Ethernet ports, like port 1 and port 2. I go to this port, like interface, range, X height, what your station you're using, the port numbers could be different. So you can look at the topology. So let's say in this example, it's port 1 and port 2, right? So I go to port 1-2 over here. Yeah. Go to port 2. And the idea is the DCB map. So the map that you created, right? This map, that has all the settings, ETS, PFC, DCB, applies on one port. You need by DCB map. And there is an FCOE, but as we that is used for FCOE. Even that needs to be applied on these ports. So you can see FCOE map, sand fabric. So I go to the port 1, port 2, apply FCOE map as well. So DCB and FCOE map needs to be applied on port 1 and port 2. Okay. Then when the fiber channel interface, I mean, this we are done with Ethernet. We apply both maps. The channel have this interface over here. If you look at it, to this interface, the only thing that we apply, so we take the FCOE map, we apply to fiber channel interface number 52. That's exactly what you see here. Interface F50. I go there, I apply the map. So I'm going ahead and applying this map. So this MX configuration to act as a fiber channel forwarder completes. The only thing that is left now, you're going to the brocade switch and doing zoning. Like I would like to have Windows, this blade 1, CNA, talking to that compellent storage, blade 2, talking to compellent storage, two separate groups. We have to go ahead and create a group. Okay. Since see in I can create an alias to use long WWN number. I'll go ahead and create an saying yes, station number 1, Windows CNA. Okay, let's say that's the alias name. The actual WWN number, 64-bit address. We can put that 64-bit address and say this 64-bit address means, alias station 1 Windows underscore CNA. Likewise, I create an alias for VMware. I create an alias for my compellent port, compellent storage. I mean, compellent, which is connected, right? Compellent will have a worldwide port name. So I take that worldwide port name. Okay. But there is a virtual port. There is a physical port and virtual port. I'll show you that later. Okay. So I use the compellent port and I go here and do create a alias. So instead of using numbers, we are using some names like station 1, CML, port station 1, VMware CNA, station 1, Windows CNA. Okay, so we are creating an alias. Okay, now we are creating a group. Saying the group name is Windows Zone. Okay, zone create. So look at the group name saying Windows Zone. Windows, it contain a Windows CNA, and so I'm taking this Windows CNA alias along with CML port. So Windows and compellent put together in a zone called as Windows Zone. There's another zone created, VMware Zone, where a VMware CNA and compellent is put together. So we have two zones. Okay, we have a Windows Zone and we have a VMware Zone. With this, two zones created, just go ahead and put it in the configuration file. So we create a configuration file called as whatever, pod, any name you can give. So as an example, pod X, let's say pod 1, and I say Windows, this particular zone. And this zone will be part of this configuration file. And I say activate the configuration file. CFG create is to create the configuration file. CFG enable is to aid that you created by whatever name. Yeah. So with this, your FC switch configuration is done. You just have to go ahead and check if to see Windows ESX talking to the FC switch, compellent talking to the FC switch. You can see it in the name server of your FC switch. And then if they are able to see it in name switch, you can go log into Windows and ESX and see if the LUNs created on compellent show on Windows and ESX. So here is, yeah. So I'll explain this to you again with, as we go through the course. But I just want to check with you guys. Are you clear that needs to be done to fiber channel forwarder? What is a DCB map? What is an FCOE map? All of you kindly say yes, or you can say no, yes, no. Maybe you want me to repeat something. Do let me know. So, do you guys understand? Guys, question. Do you understand switch as fiber channel forwarder? Okay. Yeah, Lynn. Go ahead, Lynn. Okay. The whole thing again? All right. Okay. Just give me, not the whole thing then? Oh, okay. Config, right? Yes. The whole configuration, right? The whole configuration. Lynn? All right. Okay, no problem. Just give me 5 minutes, okay? Let me explain. All right. Is that okay with you? Okay, Lynn, hello. Lynn, you're back. Okay, let me explain this again, okay? So what I was talking about, like, in this setup, first, understand the topology, okay? CNA connecting to MXL, MXL connecting to FC switch, FC switch connecting to your component storage, okay? So first, for MXL to connect to FC switch, which is fiber channel, you need a fiber channel port. You need a fiber channel port. So MXL switch, right? MXL. Um, your MXL switch, you have a module. So this is your MXL switch. If you look at this picture, this is your switch, an example of how an MXL switch looks like. Okay, these are all pictures, which is a blade switch. Now this switch has an option. You see this, MXL switch. There is a filler. This filler, you remove by modules. You have options of buying or module. This one, FC module, which gives you native fiber channel ports. So you buy this, and you install it. Buy this FC module and install it in your FC switch. FC switch. Yeah, so these are all pictures, okay? So if you look at it, these are all pictures. Your MXL switch, where you can open that filler and you can, install that. The module name is FC module. You can install. So you install to the brocade switch. Let's say FC port is 650 that you purchased and you installed in your MXL. You have to enable the feature called as FC. So that's step number one, is to enable feature called as FC. Okay, which are supported. It can send fiber channel frames. However, you should understand that from the CNA to your MXL, it is all, it's all going to be FC OE. It is not fiber. It is this FCOE thing, which you are sending from here, from the CNA. You send FCOE frames, MXL. It's only your MXL that converts FCOE to FC and sends this to the fiber channel to the storage. And when this is sending FC frames to your MXL will go ahead and have this OE traveling through that Ethernet link to your, CNA cards. So that's how it works, right? So we want our MXL to play the role of a fiber channel forwarder. Now, what does a fiber channel forwarder do? Well, a fiber channel only acts as a translator. you can see that a fiber channel forwarder is the one that translates your fiber channel over Ethernet to FC and vice versa. But it doesn't do fabric services like zoning and all that. It doesn't do that. Okay. So you need this switch to act as a translator. Now, I told you that this FCOE traffic is traveling on this Ethernet link. Your fiber channel traffic is traveling on Ethernet. Your Ethernet, I mean, this part, this switch, which is acting as, I mean, this is Ethernet, right? Switch with a fiber channel module. This the connector, the connectivity from here all the way till here. That's what we learned, saying that it has to be lossless. We learned that, saying that sending C frame over Ethernet, there is a risk of your frame getting dropped because Ethernet network is lossy network. So you want your Ethernet to become lossy. Only then FC frames can be sent over Ethernet because FC is known for reliability. That is why FC recommends you to implement data center bridging. It recommends you to implement data center bridging so that you're lossless. You know, your Ethernet becomes lossless. So the question was like, okay, what is DCB? I took a DCB steps like the priority, prioritizing one traffic the other. TS deals with bandwidth reservation, and DCBX it checks for settings that are matching between all the DCB and so you have to implement PFC, ETS, and DCB. Now, to implement PFC and DCBX, we could be saying, you know, DCB map, let's say this map is learn it's a map saying it's yeah map, let's say Lin, okay, Lin DCB map. And what I'm saying is this map that you're creating, Lin underscore, has two groups. Number 0. Number 1, what is this priority group? Well, priority group is nothing but, I said, the type of traffic. In this airport example, where airline company has different type of customers who want to actually board that flight, you know, through that common boarding gate. They all want to get into that boarding gate and board the flight because there could be network congestion. I mean, there could be some, you know, there could be congestion happening here because this is just one boarding gate and you got so many people who want to enter that boarding gate. Through the boarding gate, they want to board the flight. What we are doing is first we are categorizing, saying, okay, what type of passengers we have. We classify them, saying economy, business class, and so on. Okay, so this classification of type of called as traffic class QoS group, also known as priority group in OS. Now, since we are talking about OS 9, OS 9, we are saying that priority group, priority group, there's a group 0 and there is a group. These two, yes. Group number 0, group 0, we are saying group 0, bandwidth, I would like to set it as 60%. And that's my requirement, or that's Lynn's requirement. He can change that. He can change like 80%, 20%, 30%, 70%. That's okay. And then when we talk about PFC with a priority flow control, should be enabled or not. PFC is something that we would like to go ahead and enable for traffic, which is critical. So I see group number 1, traffic. I'm saying I would like to enable PFC. Just like group 0 is a normal Ethernet traffic. But group 1 is important traffic. So we would like to enable, priority flow control for group number 1. That's group PFC setting being enabled. For group P. And like I said, the moment on a switch, if you enable ETS, PC, DCBX protocol gets your data center bridging exchange protocol gets in. Okay. Oh, great. So we've got these 3 settings. Apart from whether it should be enabled or not, we also deal in this map called as lin underscore DCB underscore map. In this map, we also talk about what number, if there is a traffic, because if you understand, if you look at what we, the way we, one is to identify traffic between these 2 traffic, which traffic you want to prioritize. Step number 2 would be to do the tagging. So you would like to go ahead and mark, you would like to map, you'd like to go ahead and give some priority number, figure that queue as strict. So important, first, the switch will figure out that traffic, filter that traffic, and then that traffic which is filtered will be given a number, priority number, and that will be mapped to a specific queue. That's exactly we saw even in the airport example, saying that all that traffic that was filtered was given sign like DC, cabin crew CC, this one SC, SA, WC. Let's say that those are all the codes. I can use those codes. Let's say I use a code like 0, 1, 2, 3, 4, 5, 6, and 7, which is what your priority numbers are. If you look at the standard called as 802.1p, .1p, priority numbers can be from 0 to 7. I give a priority number, and then all that traffic that has a specific priority number, let's say if it is mapped to a queue, like Q1, Q2, Q3, whichever queue is marked as strict, that queue will be processed first. I mean, that is the logic that we have. So we have 2 groups. There's a group 1. What priority numbers are you giving for those groups? That is what the question is. And you can see that priority group number 1, if you look at group number 1, group number one position is 0, 1, 2, 3. Position of group number 1, you're placing it in position number 3. So it gets a priority of 3. Group 1 gets priority of 3. Remaining priorities go to group 0. So this is what that priority group ID is. So it gets a priority of 3. How? Because this one is actually placed over here. Okay, this one is placed over here. And that switch vendors, they go ahead and use, what do you call, they use, let me go ahead and use something. So switch vendors use priority number 3 for FCOE, and they use priority number 4 for iSCSI. Okay. Priority number 3 is used for FCOE. Priority number 4 is used for iSCSI. Yeah. Suppose, apart from your normal Ethernet traffic, FCOE traffic, imagine we had iSCSI traffic as well. What would a story? Well, the story would be something like this, where I would have created another, apart from group 0, there would have been another group, and the group name, basically number, would have number 2. And bandwidth, obviously, it cannot be like this, because it's more than 100. So your bandwidth has 20% of bandwidth is what I give. For, 20% is what I'm giving. That's for normal Ethernet traffic. I want to give like 40% to this guy, FCOE, or maybe 50% for FCOE, and I want to give 30% because these groups that I see over here. Group 0, group 1, group. And then, okay, how do I know what is the priority for group 1? What is the priority for group number? So I guess I told you group number 2 is meant for iSCSI. I'll give a priority of 4 by changing the value over here, saying that group number 2, priority group number 2 is something that I'm placing over here. If you look at 802 priority numbers, okay, let me go ahead and zero to 7. These are all the priority numbers, right? So look at those is the position. When I see that my FCOE group 1 is using priority number 3, iSCSI is using priority number 4. Group 2 is taking priority number 4. Lynn, did you get it? So far, yes or no? You follow me so far? Let thinking because you want to understand that getting okay, great. So your ETS, PFC, DCBX. Where is all this? This is all part of a map called as LIN DCB map. There's a map called as maps, everything. This whole configuration, right? Whatever you did is part of this small map called as LIN underscore DC underscore. Right? And I take that map, I take that map, DCB map, and I apply map on port facing it because that's where I want, Ethernet is what I want to make lossless. So I apply here, apply the DCB map there. Yeah, because that side is Ethernet. Okay. Look, your FCOE traffic requires a separate VLAN, so I'm creating a VLAN interface, VLAN, let's say LIN is station number 4. Okay, let's say LIN is 4. So um, he creates a VLAN by using 1004 or whatever it is, right? I mean, that's what so he is creating a VLAN. Station 4, he creates a VLAN 1000. And then now Lynn is creating a FCOE map. Okay. There's an FCOE map. So this is just his name saying, hey, this is my map, FCOE map, which is, okay, so let's say I create an FCOE map. Okay, what details do you have as FCOE map? I'll put the VLAN ID saying, okay, they use this VLAN for all my FCOE traffic and use this fabric ID. And so that's map is 0EFC00 by default, but X can be replaced with station number. Okay, now I created an F. What's even it contains FCOE VLAN fabric ID details. I take this and I apply this onto my fiber channel interface ports that are facing CNA, port number 1 and 2. That's exactly what I'm doing over here. You see this ports that are CNA, 1 and 2 ports. Okay, he's applying his DCV map. And he's also applying his FCOE map. As far as the fiber channel is concerned, fiber channel interface is concerned, to the fiber channel interface, we just need to apply FC interface 52, which is this, and then he applies FCOE map. With this, your MXL configuration is over. You're done with MXL configuration. This is MXL done. Now you need to create zoning. Now, or cards, I mean, your CNA card, which has fiber channel, HP channel. So, I mean, this can be pretty long. Okay, 20. Let's say you're using this long. This one looks like to me one, two, three, four, five, six, seven, and eight. So it's like 64-bit address. I mean, this is a pretty long. Yeah, so this is the case with Blade 1. Blade 2 has its own address. It has a long address. So let's say this is um, a small change to this. And your storage, compellent storage has a WW and the worldwide name, port name, something. Okay, it's got its own address. Yeah. So I would like to make sure that I create a zone that allows uh, my Windows DNA. I would like to zone it with the compellent storage. Storage separate, two separate zones. Okay, there's one zone, Blade 1 and compellent. There's another zone which includes your ESXi CNA with your, I mean, there are, okay, creating using the worldwide node name. These are long addresses. Now, it's very difficult for me to know to that, okay, this address means Windows, this address means ESX, this address means compellent. So what we do is instead of use address to this, that's exactly what you're doing on this page. Actually, you're creating an alias. And what the alias is saying, hey, yes, VM compellent. Okay, so name compellent. Okay, so there are three aliases. Alias, Windows CNA, and then so I'm creating three zones. Okay, there's you know okay two zones. The first zone includes a C. Second zone is VMware. That includes a VMware. I two zones. So there's a configuration file. So let's say this is the configuration file. So you have two zones. Zone. Okay, there's a Windows zone. There's a Windows zone, and there is a VMware zone. I have two zones created. What do I do with these zones? So with these two zones, what you do is you first create a configuration file, config file. Okay, so you're creating a config file, configuration. The configuration file, you can do anything. Like, okay, for example, over here, pod, pod. Okay, so say len pod. This is a configuration file. You can give any name. I mean, technically, you can give any name to this one. So they are creating a configuration file. I'm creating pod. Okay, what do this zone? Put it in the file, part of the configuration. This part configuration. You can configuration for two zones: Windows zone, VMware zone. Okay, we add them. Then do what? Okay, once you add these two configuration, I mean these two zones, part of the configuration file. Last thing would be what changes you made to this configuration file called as linpod. You save the changes, saying CFG save, and then it's time for you. So you can activate this file, saying that okay, let go ahead and apply this configuration. Start using this configuration. This is what you're doing as CFG. So that's what you do on your Brocade FC switch. I hope figure on Brocade, how you switch MXL in fiber channel forwarder. Yes or no? Okay, good. Good. Mm. Lynn, how about you, Lynn? Did you get like configured in these three? Yeah, okay, different modes. Great. Okay. So, do you one option where MXL is the role fiber channel. I mean, just how well. Now there could be another scenario where I see that uh, wherein I'm talking about well, ESX are connect external. One more switch, like that switch is pole of a switch. And the brocade switches playing the role of a fiber forward. So what configuration needs to be this one? Exactly what we learned in the previous one. On the switch. Switch. What about MXL? I just want MXL. I mean, switch does which is that switch converts. Is it MXL or S1000? In this example, what is who converts FCOE to FC and FC to FCOE? Who is doing the job of a translator? Which switch does the job of translation? Come on, guys. Answer. Nguyen, Chuang. Who is acting as, which is that switch that is acting as a translator? Who's acting as a translator? Or very good, Sang. S5000 is acting as a translator because that is acting as fiber channel forwarder. S5000 is playing the role of fiber channel forwarder. So S5000 will do it. So what should MXL do? What should MXL do? MXL do nothing. Just send, just act as a transit or pass through. I don't want MXL to do any changes. I don't want MXL to make any changes. I don't want MXL to play the role. I mean, I don't want MXL to do anything. I just want MXL, when FCOE frame is sent, one port facing CNA is called as downstream port. Port facing your fiber channel forwarder is called as upstream port. You take it from this and give it to this port. That's it. Let your S5000 do the conversion. And when there is a packet coming from this side, take it from this port and then give it to, the CNA facing ports. So in short, what we are saying is your CNA will be generating FCOE frames. They come to this MXL switch. I don't want MXL switch to do anything. I just want MXL switch to act as a transit switch. Take the frame, forward it to this. Take the frame, forward it to this or this. But that's all that I want MXL to do. I don't want MXL to do any kind of conversion because MXL should act as, a transit switch. All of you agree? Okay. So you just want to act as a transit switch. Okay. So if you remember, I told you is a transit switch and does not do translation or any kind of zoning services. What is that switch called as? FSB. What does FSB stand for? FCOE in protocol snooping bridge. This is called as FSB. FSB meaning FCOE, initialization protocol, snooping bridge. That will act as a transit switch only, does not do any translation or fabric services. Such a switch will be called as FSB. So in our example over here, when you look at the example over here, MXL is playing the role of a snooping bridge. Is that clear, all of you? MXL is a snooping bridge. The port facing CU, stream ports facing fiber channel forwarder will be called as upstream ports. That's the terminology used. You get your regular 15-minute break because I'll be back and then, okay, do you want a minute before later? Or do you want to wait for another? Okay, yeah, sure. Just give me 2 minutes, okay? 12, I get take. Give me 2 minutes. Yeah, take a quick 2 to 3 minute break. Let's go to the restroom quickly, come back, and then we'll start. We'll talk about what configuration needs to be done from snooping bridge. We know what needs to be done for channel forward. We'll see what should we do if we want to use a switch as a snooping bridge. Okay, so we'll start this in about, you know, 3 to 5 minutes. Thank you. all of you. Okay, in the in example, we just learned like how to configure to act as a fiber channel forwarder, meaning we just learned about fiber channel forwarder. Okay, how you configure fiber channel forwarder, so over here, I see original. Okay, so there's IP snooping bridge. We have to make we enable the feature saying enable FIP snooping protocol. So this is step number one on your MX. We ourselves tranche a pass-through switch and on the command feature FIP snooping. This enables FIP feature. And then we enable the protocol on that unstable. Once we enable, so what next? Well, the next thing is go ahead that are facing, I mean, port number 37 and 40 are facing S5000. S5000 is playing the role of a forwarder. So the ports that are facing fiber channel forwarder should be configured as upstream ports. Actually, we're going to 37 all the way to 40, 37, 38, 39, 40. Four ports. So I'm going to these ports, and these ports, what I'm saying is, hey, there is already CB. Uh, buoi map, which has details about FCOE and all. And there's a LIN, PS, PFC, I want this, as the same, ETA, ETS, PFC, and priority number. Okay, so I want MXL to learn that, and that is why we are saying Hill switch, MXL switch. Um, Noise. You don't advertise your settings. Instead, you be okay in receive mode. Good. What do you have? Okay, here telling is you be in receive only mode. Receive, which is REC. So we are saying MXL. Hey, MXL, you don't advertise your cap. I want these ports receive only mode. So when you say receive only mode, that means it's configured over here. You just receive it. You don't advertise. I don't want MX advertise to but RECO actually means receive only. So I'm saying, hey, port number 37 to port number 40, yeah, do not advertise type length values. Your ETS settings, receive only. Whatever ETS settings configured here, just take it. Okay. Look, you are a port. The ports over here. These are ports facing the fiber channel forwarder. So these ports should be configured as stream ports. And that's exactly what you do. We're saying port number 37 to 40. Well, the role, your port role is upstream, auto upstream is configured as stream port. Do you understand? Okay. Upstream means port facing the fiber channel forwarder switch. Downstream means ports facing CNI. Is it clear, Nguyen? Okay. Upstream DCB settings and pass it downstream ports, meaning it takes configuration, your DCB from fiber channel forwarder switch, in this example, and gives it to Windows and ESX CNA. So say MXL is 5. You say priority given. This what about others in the class? So we have to configure port, these upstream ports. You go to the port and you see BX port role. This will make, I mean, plan over here will make port as upstream ports. So this is command for you to make it upstream. Okay. What about downstream? Like port and 2 facing the CNA, make it downstream. You go to these ports, I mean, you see interface range, let's say port 1 and 2. Yeah, in range port 1 hyphen to these ports, and you can see the role, the port role is configured as Lin, Sang, Chua, and port either upstream and down. Okay, then if you look at VLAN, if you remember this FCOE map, let create, I don't know, VLAN was something VLAN 1004. That's VLAN BRML, same VLAN. I'm saying whatever map, FC map that you created, that's the same map that should be used here. And then make sure that you're enabling FIP snooping, okay, on that VLAN. So FIP snooping in on that MXL switch. Yeah. So on that interface VLAN, 104, which carries your FCO, go ahead and enable FIP snooping. With this, you complete configuration on MO. What you just saw is a switch being configured as, how we can have a switch being configured as early how to go forward. So do the zoning on Brocade. Okay, first you start with MXL, do the configuration on MXL, okay, as snooping bridge, and then S5000 configure it as fiber channel forwarder, and do the configuration of the map on S5000, and then go to FC switch and do the zoning. That's it. So whatever LAN that you have created over here, this LAN should be to you in Windows and ESA. The whatever you've created, and EX. All clear? Yeah. So this is example number two where I see um, a switch acting as a snooping bridge. Okay. Now I told you that there are three modes that your switch can basically work as. A switch can act as a bridge, a switch can act as fiber channel forward, and a switch can act a full switch that is full fab. Okay, that means it is acting as a fiber channel forwarder. Like you use a switch. So take an card connecting to MXL directly. It's connecting to MXL directly. So MXL has FC storage connected directly to this. You know, yeah, FC storage is connected to MXL directly on this fiber channel port. So we want this switch to be configured in full fabric mode. That means not just act as a fiber channel forwarder, because we are not using any brocade switch. We are not using any switch to do the job of a fiber channel forwarder, plus take care of fabric services. Yeah. So this is when you configure a switch in full fabric mode. So what configuration do we do on a works? Let's say that works in full fabric mode. Well, let's have a look at that one and see if that is something that. Let me explain you this. Again, I've got some topology here. In this topology, I'm not using brocade. No brocade. Compellent connecting to S5000. S5000 wasn't full. It will be a snooping bridge. We know what configuration needs to be done from the snooping bridge point of view. So we're just looking at S5000 play role of full fabric. Then what? A full fabric is what? A full fabric is nothing but a switch that basically it acts for the. I mean, that's what a full fabric is, something that plays the S5000 is playing the role of a fiber channel forwarder plus taking care of fabric service. Okay, so what do we do? A switch which is acting as fiber channel forwarder. This one, FCF, that's something that it does. Okay, so what do we do? Fiber channel forwarder, S5000. Okay, normally whatever we do for enabling fee, because this port is going to be fiber, so feature FC should be there. But the key thing is act as full fabric. This is the command. FC switch mode fabric services. This will make your S5000 act S5000 act as full fabric. The command is FC switch mode fabric service. Full fabric mode of S5000. Then let's go ahead and do the normal fiber channel forwarder. It will have a DCB map. Like we created LIN DCB map. You can see that there is a DCB map which has two groups and bandwidth and PFC setting, and it has the FCO. You have an FCOE map. This is the name of an FCOE map, which will have FCOE, VLAN ID, fabric ID. And then we take the DCB map, we apply it to Ethernet side. We take the FCOE map, we apply it here, and we apply FCOE map this side. So we are, because the self is acting as full fabric. So the DCB map and FCOE map will be applied over here, okay, onto this port. Okay, You can 12 to 25, whatever ports you're using. These ports, I'm applying DCV map and I'm applying FCOE map, whatever that FCOE map is. Okay, that's all you do from the fiber channel forward side, right? Fabric services. What do we do for fabric services? Fabric services is where we go ahead and start doing configuration. So this piece over here is specifically for on S5000 for zone. I create Windows underscore server. Now Windows underscore server is the name, the alias name, and the WW number. Saying this WW number means Windows server. This WW number means this number means compelling storage. Yeah, this means compelling storage. And then, okay, we are done with creating alias. Now it's time for us to create zone. Zone is called as a zone set. Okay, so I'm creating. Okay, I haven't taken the screenshot for zone. Zone says about creating alias, and after creating zones, I take the configuration file, which is called as zone set. The file is zone set. Configuration file is a term that is actually used. It's a term that is actually used in, okay, but your Dell switches will use the term zone set instead of configuration. So we'll add those two zones, Windows and VMware zone. Okay, and then do what? We go ahead and right? We enable it. Instead of enabling, we have something called as activate zone set. That's it. Whatever your zone set is, active underscore zone set. That's a name. So we are saying, okay, I would like to go ahead and activate this zone set. This is zone set name. We are done with switch configuration in as full fabric mode. Hope you all got it. Snooping bridge, fiber channel forwarder, full fab mode. There are three modes that you can configure the same switch. Depending upon the topology at the customer site, you can configure as switcher configures full fabric mode. Okay. Time for us to go ahead and take our lunch. I'll tell you how you can go ahead and do lab. I'll explain you the lab. Do lab for the rest of the day is only lab. Okay. So take your lunch break right now. It's 12 in Vietnam. In Iraq from lunch, I'll explain you how we can proceed and do the lab. Okay. So whatever your local time is, be back in 1 hour's time. Can you hear me? Did you get my email? All of you. Chuang, Lin, Sang, Wan. Okay. So, so we, okay, you guys will be doing two labs. Two labs. Okay? You'll be doing two labs. So, yes, I have mentioned that very clearly in the email. Nguyen, first lab has to look. Only then FCOE will work, okay? Did you get it, Nguyen? Okay. Before, okay, read my email, please. Read this line. Before you do exercise one, yeah, because I want to give you a spare station, free station. I said, okay, I want you to use that separate station. I was using that. We've got like, I don't know, 10 participants in the class, and we just have 8 stations. Somebody needs to do sharing. So I thought of giving you um, a separate station, station 4. Okay. Fuang is not there in the class. Kuan is also not there. I think you can do your labs independently. Fuang, not in the class. Yeah, go ahead, Nguyen. Station 1, you did what lab? Station 1, I mean, you were using this lab? This one? This? But you have Van also with you, right? Van, do you want to work as work together? You both want to use. Oh, okay. Okay, no problem. Then you can use station 1. But make sure you inform Van about it. Okay, okay, no problem. You can use, okay, you can use station one. I have no problem with that. Okay, so guys, read the information. Look, what you're doing, I'll explain you what you're doing on FCOE exercise one. FCOE exercise one is where I see station, I mean, station one and three, whoever is station one and three, these are your port numbers. You are connecting to MXL port one, port two, MXL 51. So in your lab, when you're doing your lab, your lab guide will tell you saying, hey, topology that is given. Ignore this. You can start from page five. And when you're doing page five, when you're doing this lab, you will see that, okay, hyphen two. If you're station two, you're using three hyphen. I gave you here saying, if you're station one and three, you're port number one and two. Did you get it? Okay, Nguyen, please help others also to understand. In case if they didn't understand, explain them in the local or your native language, okay, as to what that X basically means in the lab guide, okay? Okay, so um, follow FCOE exercise one. Use this email, use the topic that I have part of the email. You can ignore these WW numbers. COE lab guide. Okay. And look, I have your WW numbers for zoning. So one is okay. If let's say Van is actually doing it as station two, he wants to do zoning. This is his. This is the window WW number. And just follow the guide will tell you that okay when you have to go ahead and do zone is exercise one. Exercise one, when it comes to zoning, right? It says compel and storage here. So for compel and storage, what you do? Okay, so have it on email. What WW number? What for compel and what should I use if I'm station one? Okay, what port number should be used? Okay, so it says when you run this command saying show FCNS switch. Have a look at this one. Okay, let me me do this for some station. So let's say Chuang, right? This is Chuang. Okay. Show FCNS. Oh, okay, this switch is not configured. Now you configure it. So when you do that, you actually do WW numbers. Okay. Pay attention. Important. Okay. So when you run this command saying show FCNS name server switch, when you're running this command, right? When you run this command, you get this output. This is the output. This is the output. In this out for compellent, for compellent, there are two compellents. There are two of them. Okay. Um, there's one compellent WW number shown here. Okay, which I'm marking it in. I don't know, marking it in red, or maybe I'm marking it in some color, something. Yeah. So there's one compellent which shows up here. There's another one which shows up here. There are two of them. So use the second one. Use the second. It says port number. Don't use this port number. Don't use this. No, use this. Slow, okay. Use this. Don't use this. Don't use this. Use the second. Did you get it? When you have to do zoning, right? Like for example, if you're using compellent, let's say, check this out. You're creating an alien for member. Okay. Now this should be your WW number 5000D310, followed by, let's say, Chuang. Chuang will use, where is that? Yeah, let's say, show FCNS. When he runs this command, show FCNS switch, he gets two outputs. Use 3010 followed by 04A16049. This one has to be whatever shows up here. Put this entry. Use the port name. Then guys, do you understand? Sang, Dong, Chuang. Okay. Those who understand, please explain it to others in the class. If they have a doubt. Okay, Chuang, just talk to Sang. Sang, can you just explain Chuang on this in your native language? Sang, or anybody who understood. I don't know. Nguyen, Sang, do you want to explain it? Please explain. You can call and talk to Chuang, or is that yeah? Go ahead. Are you calling Chuang? Talking to Chuang? Okay, thank you, Sang. Okay, so do you guys understand the exercise one? What you need to to do in lab? Lynn, Lynn, Sang. Okay, great, great, great. Okay, now let's talk about FCOE. Yeah, okay. FCOE exercise two. Okay, exercise two. So after you complete FCOE exercise one, use okay, the same lab guide. Okay, there is exercise. There's attached. Okay, exercise two. And what this lab guide does is it says start from page 14. So the same lab guide has page 14. You complete exercise one. We go to exercise two. Exercise two has exercise two. What do you MXL is acting as fiber channel forwarder, connecting to Brocade FC switch and compellent storage. Compellent storage connected to Brocade, Brocade connected to MXL, MXL playing the role of a fiber channel forwarder. Okay, so what needs to be done? Okay, let's have a look at. Okay, so station 1 and 3 used to G, station 2 and follow G. Okay, now the email says from page 4. So okay, on this document you're starting with page 14. and do the lab 30. Okay, you're doing it till page 30. But before, after you complete exercise 1, before you start exercise 2, make sure you go to your MXL switch, MXLB switch, and delete the config in output. Please delete the config. You have to go ahead and make sure you run the command delete flash. Run this command, press enter. It says, do you want to delete the configuration? Then type reload. System configuration has been modified. Save. It says no. Say no to it. Proceed with reload. Say yes. The switch will reload. After the switch reloads, okay. Yeah, so this is the actual command, okay. So after the switch reloads, you can start from page 14 and end at page 30. Use the guide and the topology, okay, for topology guide for your reference. Your WWN numbers, I've given you WWN numbers. Here are your WWN, whatever station you're using. So today, I want you to complete these 2 labs. And then there's no more lecture. We will, so, okay. Ask me if you need any help during labs. You can chat with me in Adobe. So there's no more lecture today, just labs. We will have our next lecture tomorrow, 9:30 a.m. Vietnam time. Did you guys get my message clear? Did you guys understand? Did you guys get my message clear? Okay. So that's all I have for today. Please do reach me if any help needed. Welcome.